Right. In today's class, we are going to learn about Lagrange's method of undetermined multipliers. Here, that form will be for you. They're going to give as a function. It's going to be there, and subject to the constraint occur will going to be there. They will give you as a function. Function will be in the form of f of x comma z and subject to constraint occur will be in the form of phi of x comma y comma z is equals to 0. First step, what you're going to do here, you're going
Ma'am,
to
could you explain that? Ma'am, could you explain once more?
once again
So,
the given your function will be given to you, and constraint will be given to you. Subject to the constraint will be going to given to you. First step, what you have to do, you have to construct the form. You have to construct the Lagrangian form, where the Lagrangian form will be your step 1 will be Lagrangian function you have to construct. That will be Lagrangian function capital F of x comma y comma z, which is equals to f of x comma y comma z plus lambda of lambda into 5, lambda into phi of x comma y comma z, where your f of x comma y comma z is the function and phi of x comma y comma z is the subject according to the condition. Now after that, what you are going to do, you are going to differentiate with respect to x, y and z. Second step will be, you have to partially differentiating equation 1 with respect to x, y and z. So what you are going to get in that way, you are going dou f by dou x, which is equals to dou f by dou x plus lambda dou 5 by dou x. Is it, did you got that one, what we are doing over here?
yes, ma'am. Yes, ma'am.
Right. After that, what you are going to do, with respect to y we are going to do, so dou 5 by dou x is equals to dou f by dou x plus lambda dou f by dou 5 dou f by, oh sorry, what I have written here, wrong I have written.
Ma'am, denominator should be by x, right?
I have written in reverse. Already x with x we have written. Once again I am writing here. Dou 5 by dou x. Then dou f by dou y, it's equals to dou f by dou y, then plus lambda dou 5 by dou y. Then with respect to z, dou f by dou z, it's equals to dou f by dou z, then plus lambda dou f by dou z. You're going to make this is equals to equation number 2. Later, what you're going to do, you're going to substitute all these values is equals equal to 0. You're going to substitute according to the theory. You're going to equate your dou f by dou x is equals to dou f by dou y, which is equals to dou f by dou z, it's equals to 0. Then these equations will get
Ma'am,
changed. Yes, ma.
so we differentiate with respect to x, y, and z, and now we equate that main dou f by dou
Huh.
x, y, and z together and
First,
equate that to
what you're
0.
going to do with the function and the constraint, you're going to form it into the Lagrangian form, where lambda ka is your Lagrangian multiplier. Then you're going to differentiate with respect to x, with respect to y, and with respect to z. You're going to get it in this form. Then later, what you're going to do, you're going to make this is equals to 0. Completely these terms are equals to 0. According to the theory, they are saying that you make these terms are equals to 0, so that these terms will get it into the form of the equation. When we are going to solve these equations, from these equations we are going to get that lambda value that will be helpful for you for finding your x, y, and z as values. Then when we are going to substitute dou f by dou x, dou f by dou y, and dou f by dou z is equals to 0. Then this will get changed to dou f by dou x plus lambda. This should be small f, not capital F. Then dou 5 by dou x is equals to 0. Make that is equals to equation number 3. Then dou f by dou y, then plus lambda dou 5 by dou y, it's equals to 0. That is equation number 4. Then dou f by dou z plus lambda dou 5 by dou z, it's equals to 0. Equation number 5. Then with the help of these equations, we are going to get the lambda values. After getting that lambda values, you have to substitute back to your x, y, and z values. That going to give you the values of your x and y z values. Where in the previous class, in maximum and minimum, we were finding the whether it's going to be minimum function or a maximum function. But here what you have to do, whatever they have mentioned in the question, according to that they have to move. If in the question, if they're asking that find the minimum value, then you're going to, at last we are going to write as a minimum of a z. If they are asking to find the maximum of the function, and whatever the x, y, z values you're going to get, you have to substitute into the given function. Then you're going to write it as a maximum of that. This is your Lagrange'S multipliers. Is it clear?
Uh, Ma'am, I understood the part that we have to equate it to 0 from the dou f by dou x equal dou f by dou y is equal dou f by dou z.
Hmm?
Now we equate each of the inside thing to 0.
Huh?
But then, okay, ma'am, yeah, I understood. Yeah.
We are going to solve these equations 3, 4,
Okay,
5. This will turn into the form of equation forms.
okay, ma'am, okay, ma'am.
When we'll see the problem, it will be more clear to you. We'll see the problem.
Yes.